Okay, so in this video we will finish learning about the topic number 6 in our IGCSE syllabus, which is about Earth and space. Okay, so you will learn about the sun, the Earth, moon, the planets, basically our solar system, and how do we find day and night happening, and how we are facing the seasons. Every year the seasons repeat, and what we mean by orbits, and we learn about the motion of stars and galaxies, and how stars are born and how stars die, what happens when the stars of different initial mass die. Then we'll have a look at what is happening inside the sun. Then we'll learn about the Big Bang, which is the model used to explain the creation of the universe. And we'll also understand that the universe is right now expanding at a faster and faster rate. So let's get started. So first of all, we know that the surface temperature of the sun is 6000 degrees Celsius. It's a glowing ball of gas. It's a star, and it produces energy by nuclear fusion of hydrogen at the core of the sun due to the immense temperature and pressure produced at the center of the sun due to the gravitational force of all the matter of the sun. So at the center of the sun, the temperature is 15 million degrees Celsius. Okay. Now, why do we get day and night? Let us understand. So it's a fact that the Earth is a sphere, and that sphere is tilted. The axis of the sphere around which the Earth rotates, the axis of rotation is tilted a bit, around 22 degrees. And as it revolves in its almost circular orbit around the sun, one part of the Earth which is facing the sun receives the sunlight, and the part of the Earth which is away from the sun doesn't receive sunlight. So that part will always be dark, and the other part will always be bright and illuminated, giving us the night and day part of the Earth. So always one half has night, other half has day. And as the Earth completes one rotation in 24 hours, the sides having day and night swap every 12 hours. So that's how you get day and night. And when the Earth is tilted towards the sun, such that the northern hemisphere is closer to the sun, then the days in the northern hemisphere are longer than the nights. So we say that the northern hemisphere is having summer. And we know that summer seasons in India are around June, July. So around June, July, northern hemisphere has summer. And we know Earth is in the northern hemisphere. So the reverse will be the case with southern hemisphere. So when the Earth goes to the opposite side of its circular orbit, the southern hemisphere will be closer to the sun, and countries in the southern hemisphere will have longer days and shorter nights, so they will have summer. So during December, January, the southern hemisphere will have summer, but the northern hemisphere will have winter. So like this, between northern and southern hemisphere, the seasons are exchanged. Okay. Now also let's understand why summers are hot and winters are cold. That is because if you look at this diagram, the sunlight which reaches the Earth is almost like parallel beam of light, but near the equator, the parallel beam of light is focused over a smaller area, whereas the same energy of that parallel beam of light is spread out over a much bigger area near the poles. So this explains why the temperature decreases as you increase the latitudes. If you go towards the poles, the temperature is becoming very less, and the poles are always frozen. You have Arctic ice and Antarctic ice. Whereas equator is always hot, and you have equatorial forests. Now, coming back to my earlier question of why summers are hot, winters are cold, the reason is in summers, when it is summers, the northern hemisphere has summers, and northern hemisphere is closer to the sun due to the tilt of the Earth's axis. And when the northern hemisphere is away from the sun due to the tilt of the axis, and its position in the circular orbit, it has winter. So that slight difference in distance from the sun caused by the tilt of the Earth's axis causes summer and winter in either hemisphere of the Earth. And at exactly halfway between these two extremes, if you look here, the tilt of the Earth is neither towards the sun nor away from the sun. It is like parallel to the sun. So both northern and southern hemispheres are equidistant from the sun. So then both hemispheres have the mild climate, neither summer nor winter. So it's a transition between them. So we know that Earth revolves around the sun from east to west or west to east, and as shown in the arrow. So if the northern hemisphere has summer right now, after summer you will have autumn. So here it will have northern hemisphere will have autumn, and then it will have winter. Northern hemisphere will have winter. Look at my mouse pointer, and then it will have spring here, and then it will have summer again. Similarly for southern hemisphere it will be the other way around. It will have winter here, followed by spring here, followed by summer here, followed by autumn here. Okay. Okay, now let's talk a bit about the moon and why it has so many different phases. So the moon is a satellite, and a satellite is any object that revolves around the planet. So moon is not in the same plane as the sun, the earth. I mean, the sun, the earth and the moon are not in the same plane always. Very rarely they happen to be in the same plane, and the earth's shadow completely blocks out the moon, which causes lunar eclipse, or the moon's shadow blocks out a part of the earth, causing the solar eclipse in the regions which are under the moon's shadow. At other times we see the different phases of the moon. So this full moon is there when from the right side of the earth. When you look at the moon, the sun's full light is shining on the front face of the moon, which is facing you. So you see the full moon. Then as it goes around the orbit around the earth, it takes around 28 days to complete one revolution around the earth. So the phases of the moon are during this one revolution around the earth. So as it shifts in its orbit around the earth, the illuminated part also varies. So finally, when it is exactly between the sun and the earth, then the illuminated part of the moon will be on the back side of the moon, which is not facing us. So we will see only the dark side of the moon. So that is why it appears black, and we call it new moon or no moon. And after that, slowly the sunlight, the region lit up by the sunlight will increase. So we call it waxing. And when the region lit up by the sunlight decreases, we call it waning. So the moon has waxing and waning. Now to understand orbital speed of any object which is traveling in a circular orbit, it's basically a speed is distance by time. So circular orbit means circular path, which means circle's circumference, which is given by 2 pi r. So that's why the formula here is distance is 2 pi r, and the time taken to complete one circle is called the orbital time period. So it's capital T. So for the moon, the radius is 3.84 into 10 to the power 5 kilometer, and time period is 27.3 days to complete one orbit. So its orbital speed is 3.6 into 10 per 3 kilometers per hour. Like that, you can find the orbital speed of the Earth and orbital speed of the Sun around the center of the galaxy, and the orbital speed of the galaxy also you can find if it is orbiting something else. Okay, we will stop here for now and continue in the next video.